My name is Vishnu Punik. Today our presentation topic on Deltaic Reservoirs. Today we will cover case studies on Northwest Hutton Field, UK, North Sea, which is an oil field, and Seneca Ville gas field, Grandsnake County, Ohio, which is a gas field. Both of the fields are now in run because they have faces depletion in their reservoir properties. Northwest Hutton oil field, which is discovered in 1975, located in northern North Sea in UKCS block 211 by 27, which is west to Norway and northeast to the United Kingdom or UK. The operators of the oil field was Amoco UK Enterprise Oil Mobile North Sea. Here is also a map in which we can see the offshore oil field location area. The regional settings of the Northwest Hutton field. The oil field is situated in East Shetland Basin. The geological structure is complex tilted fault block. Basin features normal and rainfall system, reflecting complex interaction and sedimentation control during multiple phases of drifting. It is a deltaic deposit, and here we can see a seismic log section. So here we are going to see the stratigraphy of Northwest Hutton field. In this gamma ray log, we can see there is heterogeneity in sand and shale. So we can identify that here is a deltaic deposit. And we can see also which is identified or marked here shale sand alteration. So we can clearly identify that here is a marine environment or deltaic deposit system. I have marked this with red box, which was our targeted reservoir, and it is the Middle Jurassic brain group, especially the basal coarse groom formation, in which we can identify bell-shaped log diagram, gamma ray log diagram, that here is a massive sandstone unit and it is a good reservoir for our oil production. I have marked also the groom formation, which was our targeted reservoir. Structural map of the Northwest Hutton field. And here we can see the structural map of Hutton field, and here we can see several blocks and wells marked here. So we have cross section the area, and here we can see some fault, thrust fault, and the closure have generated due to the fault thrust faults. And here there is the brain group formation, which is sand layer, and the upper header formation and Timmins clay formation act as seal or cap rock, which is shale rock formation. So deposition system, there is two systems present in the Hutton field. One is upper system and another is lower system. The lower system is the broom formation, and the upper system is represented by 5 main depositional phases, which are marine offshore to shore phase transition, lower shore phase with storm wave infused sandstone, upper regressive shore phase to coastal plain transitional zone phase, and coastal plain environment with lagoonal and fluvial influences, and last one is transgressive coastal plain to shore phase transition. So here we can see the upper phase is also marine or transitional system, which is indicating that it is a deltaic reservoir. The phases characteristic of the field is the broadly uniform phases in upper shore phase to coastal plain sediments. The planning of phases evidence suggests that varying salinities in coastal plain marsh. Lithophasis distribution indicates depositional in strand plains or barrier coastal settings. Here, lithophasis of the Northwest Hutton field. Within the brain group of the Northwest Hutton field, 5 major reservoir phases and 2 non-reservoir phases identified. The 5 major phases are, which number 1 is sublittoral sheet sandstone, number 2 is distributary mouthparts and delta form sandstone, The next one is Kivas Clay Sandstone, Distributary Channel Sandstone, Shallow Marine Sandstone and Claystones, Lagoon or Bay Silty Claystones, and the last one is Deltaic Overbank Deposits. Here is some photograph of core samples. And the first one is core photograph, which is the showing distributary Malkbar sandstone from the Etic formation in OL 2011 by 27 A22 block. A22 OL. The second one is the core photograph showing distributary channels sandstone from the Ness formation in OL 211 by 27 A22 OL. And both of the core samples are taken from depth more than 12,500 feet, and the sediments are here mainly coarse grained sandstone. Okay, here is also a map showing the Kivas plate that generalized distribution and orientation of distributary channel sandstone in the lower Ness member. Here you can see the distributary channels where they have been deposited. Here is also in the right corner the distributary channel sandstone distribution in the upper Ness member. So both in comparison, here is the distributary channels more scattered than the first one. Now, reservoir petrography and diagenesis. Framework composition. Mostly quartz grain are observed, but some elite, feldspar, mica and other lithic fragments are also observed in the petrographic microscope. Pore filling minerals include quartz overgrowth, which is we can see here quartz overgrowth, calcite, kaolinite and elite. In this thin section, we can see quartz grains, pore space and secondary pore space and also kaolinite. Here we can see two same photomicrograph of upper Ness member regressive shell sandstone. Here we can see quartz grains and kaolinites, and in this photo we can see quartz grain with pore space and elite. Elite also we can see quartz overgrowth here, and the elite concentration at depth increases. It impacts negatively on the reservoir quality. It blocks the pore spaces of the reservoir. Reservoir characteristics. Core distributed channel sand display the best properties, while delta form sandstones have poorer quality. Diagnostic factors impact reservoir quality. The productive limit is defined at 12,500 feet subsea with oil water contracts structurally controlled. In this section, we can see the depletion of reservoir quality due to diagenetic properties of the reservoir. Now, production overview. The oil field came on stream in April 1983 with A1 oil at 211 by 27 block. Production peaked at 86,680 BOPD in May 1983. Artificial lift was used in this oil field, which was produced to gas began in October 1984. The oil field contains an estimated 670 million barrel oil. Recoverable reserves is 200 to 220. Recovery factor is 30%, which is good enough. Reservoir heterogeneities pose challenges with pressure variations and Hubson's effective sweep efficiency, which can be shown in this diagram. As depth increases, the sweep efficiency also increases, and the depletion of the reservoir quality also increases. We can also see from this diagram that the permeability of the reservoir is decreasing. Exploration and production strategy. Identify to exploration here and work over here. We all have to identify and map reservoir structure of the oil field. Then we have to understand internal architecture and physics variability of major sandstones. We have to consider traps relation to structural depth for reservoir quality and optimize injection to enhance sweep efficiency, especially in channelized sandstones. Here is the production decline curve from 1983 to 1988 of the Hutton oil field. We can see that in 1983 the production was at peak, and in 1988 to middle of 1988 the production at its lowest level, where the production is ended, and in 1986, middle of the 1986, the production was at its lowest level. After that, the gas injection was introduced here, oil field. Conclusion: the Northwest Hutton Field's brain-proof reservoir consists of delta ponds and distributary channel sandstone shaped by a wave-dominated delta. The reservoir quality is primarily controlled by depositional phases. Coarser grain, clay, peat, fluvial and deltaic channel sandstones exhibit the highest reservoir quality. Finer grain sandstone in delta and shelf settings with abundant orthogenic clay show reduced permeability, which I showed in the previous curve. Burial depth below 12,500 feet results in extensive quartz and clay cementation, leading to poor reservoir quality. Successful development requires a comprehensive understanding of the depositional environment, lithophasis, diagenesis, and complex fault effect. Now, the Seneca Ville gas field. The gas field is controlled by Deltaic Division located in Ganche County, Ohio. Operators is Consolidated Resource of America Enterprise Energy and Gaspro Incorporation. And the gas field was discovered in 1971. I have found this map from Google Earth, but no proper map I have found from internet, because most of the Google's result is showing that it is a power station. Maybe it converted into power station, that's why no present map is found. Regional settings. The gas field is located at Appalachian Basin. The tectonic regional paleo setting is Cratonic Basin. Three main regional settings are described for the lower Silurian clastic waves. Number 1 is Eastern Non-Marine Alluvial Coastal Plain. Number 2 is Transitional Deltaic Zone, and the last one is Western Marine Offshore Zone. In this map, we can see that Clinton production trend and major structural feature of the Appalachian Basin and Ganche County, Ohio. This is overall the play map of basinal map of the area. Now, stratigraphy of the gas field. Reservoir rocks. Our reservoir rocks age is early Silurian. The stratigraphic unit is Clinton formation. The lithology is well sorted and clearly fine to fine grains sublithate arenites. In the stratigraphy of which is made from wireline log, we can see the Clinton formation show heterogeneity, and in the lower pivot head shell we can see neutron density negative separation, which is indicating there is hydrocarbon present. Lithophasis. Productive phasis is our distributary channel sandstones, point bar sandstone, distributary mouth bar sandstone, which is identified from the gamma ray law. Petrophysics is porosity type is intergranular. The porosity of the rock average is 8% raised to 2 to 16%, cutoff is 4% from log. The permeability of the reservoir is average to 0.5 millidarcy, range to 0.01 to 5 millidarcy. Saturation of water is average 20%, range from 10 to 60%, and cutoff from log is 30%. Depositional settings. Depositional environment is our deltaic river dominated reservoir. Stable cratonic areas foster river dominated delta systems with deep oriented, elongate and lobate delta-formed sandstone bodies. The Claysville Delta in Gansu County progressed southwestward with continuous distributed channels, while the Salt Fork Delta had continuous channels forming thinner multi-story mouthbar deposits. Reservoir geometry. Here is a production contour map on the first 6 months of the gas production of the Seneca Ville gas field. The depth of the well is 5,600 feet. The aerial dimension is 1 by 3 miles. The productive area is 1900 acres. Here we can see that the peak production or main production is usually from the center part of the map. The number of reservoirs here is 7 and number of play zones is 3. The gross thickness of sandstone is 185 feet. Now production overview. So in this gas field, 85% of our production was gas. Hydrocarbon source was upper and lower cathode head shells. Shells act as both source and seals. Over 150 individual fields identified in the two deltas in Gansu County. Formation porosity ranges from 2 to 16%. Production decline, hyperbolic decline in the Clinton production. Here we can see that it is a hyperbolic decline. Well life ranges from 5 to 25 years. Average well life is 15 years at current economics. I have used this reference John Barwis and John McPherson Sandstone Petroleum Reservoir book. Thank you.